Right. Um, yeah, you guys let me know if you hear me or not. See me? I'm gonna share the screen as well. I want to see if that's working. Amazing.
Everyone was
Oh,
asking.
hi. It's working. Can you guys hear me well? See me as well. Hello?
Hi.
Hi. Can you guys hear me?
Yes.
Oh, damn. I feel like how the teachers feel like.
But not actually.
Is that everyone?
Hi. Thank you for doing this.
No problem. My pleasure. If any of your friends can't get in or something, send them the link because I'm not getting any more.
Are we recording this lesson or like this time?
Yeah.
Okay.
I'm recording it.
Thank you.
No problem. The whole thing should be recorded. Can you guys see my screen? Can you guys see my screen now or not? Yeah. Amazing. Right. So is everyone okay to start then? Hello? Did I lose you guys?
Yeah.
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 All right. So go ahead and start the meeting. So first of all, I've heard that a lot of people have been struggling with chemistry, knowing that it's not such an easy subject. And the university, what they tend to do is they tend to skip over really important stuff and then give you the hard stuff. And then you're left there thinking, well, where did that come from? You know, so today I'm going to try and clarify the stuff that they skip over. So first of all, introduction. Who I am. My name is Karim. I'm a second year student. You can see here. Have sorry. Sorry guys, just a second. Yeah, that's why you don't do meetings at home. Anyways, yeah, as you can see here, I'm a very friendly guy. And you guys, I want to let you know that this university is an amazing place. You're going to meet a lot of good people here that are going to basically end up being your family, like I did. So first thing we're going to cover today is pH and buffer capacity, like the capacity of the buffers, what's acidosis, what's alkalosis, and basically all the stuff that you guys went through in the first lecture. So first of all, this is the first screen that the chemistry teacher showed you guys. And I'm sure that if anyone asked me straight away, what does this mean? I'd be completely clueless because it's kind of unrealistic that they expect you to understand everything going on here without telling you what everything means. So first of all, there we go. What's an acid and what's a base and what's a buffer and what's a pH? All this stuff. I know it might seem daunting at first, but it's not as hard as it sounds. So first of all, an acid is any substance that acts as a proton donor. You know, so a proton is a H plus. So let's say if we have hydrochloric acid, which is HCl, the HCl will give away its H plus, so it will be just Cl minus. Okay, but in this case, it's acting as an acid, right? So we've got an equation here: Ha plus B gives you pH plus and A minus. HA here is giving away its proton. It's telling the B, okay, you can take my proton now, I don't need it. And the B is acting as a base because it's receiving the proton. So anything that receives a proton is a base, and anything that gives a proton is an acid. I'm sure most of you guys know this already. So what's a pH? A pH is basically a measure. Okay, so the lower the pH is, the higher concentration or how much protons there are in a solution. If the pH decreases, that means it's more acidic. If the pH increases, it means it's more basic. So if, let's say I have HCl, which I think pH 2, so what that means is that it gives away its protons until the concentration of the solution reaches a certain level. Here I've left a chart. So that's the pH, each pH and the concentration, the equivalent concentration of the protons. So yeah, here you can see. I think, yeah, there's still people trying to get in. Sorry, guys. Okay, so that's exactly what that means. That's what pH is. It's a measure of the concentration of protons. But the way you calculate it is kind of weird. So it says here, negative log of H plus. And you don't need to know the mathematics exactly behind it. But what that means is that it goes in factors of 10. So the difference between pH 1 and pH 2 is a factor of 10. That's 10 times more concentration. Well, less concentration. And that's what that log means. And you should, if you guys got any calculators, you should find the log sign on it. And negative, because it's inverse. So if pH increases, concentration of H plus goes down. Everything clear so far?
Yes.
Yes.
Yes. Yeah, if you guys, obviously this is not like a proper lecture, so if you guys got any questions, feel free to interrupt me. I really don't mind, you know. And when you react an acid and a base, you get salt and water. What the salt is basically a compound of positive and negative ions. So like table salt, sodium chloride, you have sodium ions and chloride ions. Put them together, you get salt. So now we go into the big boy stuff, the more challenging stuff. My computer decides to let me. So buffers. So now we know what an acid is. Now we know what a base is. When you add protons to a solution, it becomes more acidic, right? Because the pH goes down. You're adding more protons to it, you know? When you take away the protons from solution, it becomes more basic. You see, if it worked straight like that, if it worked straight away like that in our bodies, it would be kind of a problem because let's say I drink some lemon juice, well, my blood would become acidic and I would have something called acidosis and I would die. So that's not good. What's the body gonna do to kind of fight it? What the body does, it has systems, buffer systems. You have acidic buffers and basic buffers. But for now, we're going to focus on acidic buffers. Here I've attached a picture, you know, you can see my beautiful pen, my pencil, and it explains basically what happens. When an acid is added, it gives away its protons to the solution. So the solution becomes acidic. So how the system fights that is by reacting with the extra protons. And it says, okay, well, I'm going to take that H plus, the protons, so that the solution doesn't change too much in pH. It kind of takes it away already. And that's the salt. And we're going to go through that more in the next slide. And when you add a base, what happens is that it says, well, now that you're taking away protons, I'm going to give you more so that the solution doesn't become too basic. Hopefully that makes sense. So this is a reversible reaction. Like we can see here, the dissociation of acetic acid, CH3COOH, and water goes to CH3OO minus, which is the salt, and the ionic product of water.
Sorry, but where are we right now? I can't see.
You don't see my screen.
I can see your screen, but I don't know where you're like, where you're.
So right now, I'm going to go to Ka soon, but no, I'm focusing on the equation. There's a chemical equation here. I don't know if you can see it.
Okay, yeah, okay.
Yes, you see exactly. So that's what I'm talking about. So that's kind of a buffer system. That what I was saying is it's reversible. So it can go to the right or to the left. Okay, depending on how much acid or base you add. Because it reacts to kind of keep it in the middle, keep it neutral, if you get what I mean. So yeah, that's that. Anyways, how we determine how much to the right, to the left it is by something called Ka. So I know it's going to sound kind of complicated, but I promise you it's not. So here we have an equation, a mathematical equation, Ka equals A minus times by H plus over HA. First of all, the brackets mean concentration. So now we have the concentration of the HA, like you said before. Hold on. Like in this equation, the one next to acid here, if you guys can see my mouse, this is an acid, okay? And this is the base. But anyways, what we're doing here is we're getting the concentration of the acid and the concentration of the protons, which is the H plus, and the concentration of the salt. And we're trying to determine how much to the left, so how much is reacting and how much is reacting back, and how much is staying as it is, if you get what I mean. I know it sounds complicated, but it will make sense in a second, I promise. So remember this equation for now. Ka equals A minus and H plus, which are the products, which are the products. And then we have the reactant, which is HA, which the acid dissociates. It separates into H plus and A minus. Okay, so now that we know all this, let's return back to the screen, to the first screen, what the lady said, the professor. So we know the pH is negative log of H plus, okay? And we know that Ka is reactant, products over reactants, concentration of products over the concentration of the reactants, okay? So I want you to look at the part on the left. I know my handwriting is awful, but try to understand as much as possible. So what I'm trying to say here, hold on, in this slide, oh, okay. Yeah, there we go, is how we got to the Henderson-Hasselbalch equation. Okay, so let's say we have Ka, we have the value of Ka here, and we have the concentration of the acid and the concentration of the salt. Okay, so how do we get to pH from there? Okay, so first of all, in order to get to pH, well, pH, it has H in it, and it's a measure of acidity or how basic it is. And in order to find pH, we need H plus, which is the protons, the concentration of the proton. So how do we find the concentration of the protons? Well, back in school, what they used to say is you need to make something the subject to find the value of it. So we have everything else in here. Look at the Ka on the left side of the screen. Well, I'm trying to point at it. Well, sometimes the mouse just disappears. Here. So here you have, we need H plus. We have Ka. We have the concentration of the salt. This is the salt, everyone. And this is the acid. So what we do is we rearrange it. Okay? Good old rearranging. If you guys got your own triangles, I don't know how everyone does it. But yeah, so you rearrange it to get concentration of H plus. And from that, you put negative log, get the pH. That's all there is to it. pK here, this pK, all it means is negative log of K. That's all it means. So what I'm going to do here, how we're going to find the pH of a buffer is going to have the concentration of the acid and the concentration of the, where's the house? Yeah, the acid and the concentration of the base, and we have Ka. We just need to rearrange that to get the concentration of H plus. And then plug it into the calculator, negative log H plus, bang, pH. That's all you guys need to know. That's all what this is saying. So I hope now this makes more sense now that we've gone through it. If there's anything that
so okay, if I understood it right, pK is log and like everything, or
no, pK is negative
okay.
log Ka. So Ka here is it's called the dissociation constant. What this is it's a mathematical value. It's a constant. Okay. For each acid, it tells you how much it has reacted or how much it's gone to the right or to the left of the reaction. If you get what I mean. Do you?
Okay.
Yeah. So once we have this Ka, we can use it. We can use it to get the value of H plus, given that we have the concentration of the salt, which I'm pointing at here, and the acid. Okay.
Okay.
Yeah, just by simple rearrangement. But sometimes it will give you something called pKa. So all that means is negative log of Ka. That's it. Just plug it into the calculator like that.
Okay. Yeah. Okay.
So far, so good.
Yeah. Thank you.
So now we'll dive into another. Oh yeah. First of all, we have the acetate buffer. This is a very important buffer when you're filtering stuff at the nephrons, at the kidneys. But we also have something called the bicarbonate buffer, and this is where it gets interesting. So how do we get rid of waste like carbon dioxide and through the blood? Okay, so let's say I don't know if you guys can see this very clearly. Hold on, let me see. Yeah, there we go. So let's say we have a cell. Okay, all cells are connected to a network of capillaries. Okay, so little vessels, blood vessels, and these blood vessels, they have blood. Okay, they have red blood cells. So what happens is the cell is respiring, like when your muscles, they take in oxygen and they take in ATP, and they to make movement. Okay, so muscles make movement, but other parts do other things. So anything that uses energy undergoes aerobic respiration, and before it produces carbon dioxide as a waste product. So when you're breathing in, you're breathing it off to give to yourself, and when you're breathing out carbon dioxide.
Sorry, we don't hear you. I think you're a little bit far from the microphone sometimes.
Yeah, hold on.
Yeah, the volume keeps changing here and there.
Yeah, because I keep changing my distance.
So can you just like repeat everything you said one more time?
Yeah, no problem. So the
Thank
bicarbonate
you.
buffer. Everyone knows that we breathe in oxygen and we breathe out carbon dioxide. Okay, so why this happens is because your cells, okay, they need oxygen and ATP, to make a process. Like with your muscles, they produce movement. Okay, and then as they have a waste product, which is carbon dioxide and other stuff as well. But now we're going to focus on carbon dioxide. So what happens is the cells, okay, once they've done their aerobic respiration, once they've done all the process that they need to do, they produce carbon dioxide and they release it into the blood capillaries, and well, blood, you have red blood cells and you have plasma. Okay, so what happens is the carbon dioxide reacts with the water in the blood to make something called hydrogen bicarbonate, the reaction that you can see here. Yeah, there we go. Here, so carbon dioxide, water, makes hydrogen bicarbonate. Hydrogen bicarbonate, well, that's an acid, so it can dissociate. Okay, so what it does is you have the hydrogen bicarbonate in your bloodstream, okay, and it dissociates into H plus and HCO3 minus. And this form of carbon dioxide, so now it's reacting to form the carbon dioxide with the water to form the bicarbonate, and then now it's forming HCO3 minus ions, okay? And this form can travel in blood. So that's why this reaction happens, so that carbon dioxide from your cells can travel into the blood, and some of it also is diffused and just travels as a dissolved gas. But this is the main way that the carbon dioxide travels from your cells into your blood. And now, once it reaches the lungs, the reaction goes the other way. So the reaction goes from HCO3 minus, it reacts with the protons, form hydrogen bicarbonate, which then forms water and carbon dioxide. So it's released into your lungs and you can breathe it out. So exactly, that's what happens. You breathe out hydrogen dioxide, water and carbon dioxide. So yeah, that's exactly what happens. And this is a buffer system. So it goes to the right when it's at the cells, and it goes to the left when it's at your lungs, so that you can release the carbon dioxide. So far, so good? Yeah.
Hi,
So, oh,
can I
hello.
ask you something?
Yeah, of course.
Yeah, so I got a little bit excited until you explained how the carbonate thingy travels like to the kidneys. No, the lungs, I'm sorry. Like I was with you until that point. Can you just repeat that?
Yeah. So what you have is the HCO3 minus in your blood. Okay.
Mhm.
It combines with the protons also in your blood to form hydrogen bicarbonate. And then this hydrogen bicarbonate, it dissociates into carbon dioxide and water. So then you can, at your lungs, so that you can breathe them out. It happens at the alveoli. The alveoli are in touch with the capillaries, kind of like this.
Mhm.
This is the capillary and this is the alveoli. And then the hydrogen bicarbonate dissociates into carbon dioxide and water so that you can breathe
Oh
out.
my God, cool. Okay.
Good, good. So this system, it's a buffer as well because it acts, just a second, guys, acts to release the carbon, sorry, to resist the change in pH because, well, if it stayed as H plus and HCO3 minus, it would change the pH in your blood. You is a carbon dioxide, it would accumulate and a lot of hydrogen bicarbonate would be produced and a lot of protons would be produced. And then that makes a lot of problems because that's how proteins get denatured. You know, some words I'll be throwing here and there you might have heard of before. So hopefully that should help explain. But yeah, so what happens is you have this system to resist the change. But any carbon dioxide will be any carbon dioxide added will be reacted with the water, form hydrogen bicarbonate, and then you have that system as a buffer. So, like we said, it's a buffer. Okay, so now we can use the equation that we used before to figure out its pH. Okay, so but this is kind of different because now you have carbon dioxide and that's a gas. But I don't think you will be asked that question because it has a lot of other influence of chemistry in it. But yeah, so far, remember this equation, bottom. Don't know if you guys can see it.
Eh,
Yeah.
Yeah, and hopefully,
excuse-
having gone through the dissociation constant concept, you guys can understand the screen. Is it clear? Or do I need to go over it?
I have a question.
Yeah, of course.
Okay, was it because of diffusion that carbon dioxide like exhale through the lungs, or
Yeah, so carbon dioxide, first of all, is diffused into the blood capillaries so that it reacts
yeah,
with the water and forms hydrogen bicarbonate. And at the lungs, it diffuses from the blood into your alveoli, into
okay,
your
yeah,
lungs, and then you can breathe out. Does that make sense?
okay, yeah, it makes sense.
Good,
But
good.
like, yeah, it makes sense. Thank you.
No problem. So hopefully this screen is clear now that we've gone through the dissociation constant concept and everything. And if you
Really?
late, hello?
I have a question.
Yes, hi.
So the CO2, it diffuses into the RBCs because of it being converted to the products, and that's why its concentration decreases, right? That's why it diffuses in
Exactly.
down the
Exactly.
diffusion.
So what happens is once the carbon dioxide diffuses into the blood capillaries, it reacts with the water in your blood, form hydrogen bicarbonate, and then it travels through the blood as hydrogen bicarbonate as bicarbonate ions, which is HCO3 minus. Does that make sense? Hello?
Yep, yep.
Yeah. Okay. This is my roommate, everyone, by the way. So, anyways, this part is going to be a little challenging. That's why I was talking about. Now, carbon dioxide, as we said before, is a gas. So technically, you can't figure out a concentration of a gas because, well, it's a gas. You can only figure out the concentration of liquids or solutions, okay? So what we do in order to figure out the concentration of carbon dioxide we have to convert it. So first of all, it being a gas, all gases have something called partial pressure, or the pressure that they exert on a system, you know? So let's say in our atmosphere, we have oxygen, we have carbon dioxide, we have nitrogen, we have a lot of stuff. Each of them has something called a partial pressure, and that's a constant. That's the amount of pressure that they exert on the whole system. But it's a gas, it's constantly moving, creating pressure, okay? And we also have another constant, the solubility of carbon dioxide in blood plasma, okay? So when we multiply the partial pressure of carbon dioxide, which is given here, 5.32, times by the solubility. So solubility is how much you can dissolve in, or how many millimoles you can dissolve in 1 liter. Does that make sense? Okay, I'll take that as a yes. But yeah, so now that we multiply.
Sorry, can you repeat that one more time? I didn't understand.
No problem. Carbon dioxide is a gas, okay? So we technically we don't have a concentration, but we can make a concentration, we can figure out a concentration. And how we do that is by multiplying two values. The partial pressure of carbon dioxide on the system, okay? And that's, in this case, it's 5.32 kilopascals, okay? So partial pressure is how much pressure the carbon dioxide exerts, okay? Does that make sense?
Yeah, but how are we supposed to know that? Or is it something that we need to know, or?
Well, most of the time it's given. Plus, I don't think
Okay.
that you really be asked that, but I'm saying it just on the off chance that you get a question like that, but it really is a horrible question. And it
Okay.
has to do with loads of other stuff in chemistry you guys never need to know.
Okay, thank you.
Okay, good. So, yeah. Now that we've got the concentration of carbon dioxide by multiplying the solubility by the partial pressure, we can plug it into the equation, okay? That equation that we've got, pH equals pK, which is going to be given to you, you don't need to figure that out, plus log the carbonate ions over the carbon dioxide concentration, carbonate ions concentration over carbon dioxide. And you just plug that into your calculator, and it should give you pH of the bicarbonate buffer system. Sorry guys, I'm just gonna check. We probably don't have a lot of time left. I don't know how much I can finish, so I'm probably gonna have to start another meeting soon, but so far we're good. Anyways, there is a value for, or a range for value of pH in blood. If the carbon dioxide accumulates, it will, hold on, remember here, if the carbon dioxide, there's so many carbon dioxide and is going to react with the water and is going to eventually form H+, okay, which is protons. And this messes up with your pH, decreases your pH. And that, when the pH decreases a lot, you know, so that your blood becomes very acidic, it leads to something called acidosis, okay? So there's respiratory acidosis and there's metabolic acidosis. Respiratory is because when you can't expel out the carbon dioxide because of an issue in your lungs or your respiratory system. And metabolic is when it doesn't have to do with the lungs. So when let's say it's your kidneys being unable to filter the hydrogen carbonate out, and therefore the pH decreases because the protons stay in the blood. Okay. So the value for acidosis is 7.35. So if you go below 7.35, you're gonna have acidosis. And if you go below 6.9, you're dead. So yeah, that's not good news. But we can also have it the other way, alkalosis. So this is when the pH increases. If we go back to the system, let's say that there's not enough protein. Okay, therefore you cannot, some bonds will be broken. Oh, hello. Yes. Amazing. So yeah, if you don't have enough protons, then certain bonds like let's say between your proteins and the integral proteins, everything that keeps you together, are not going to be able to stay the same. And therefore you get something called alkalosis. Your blood becomes too basic. You're basic. But yeah, sorry, that was better. But anyways, if your pH goes above 7.45, you will experience alkalosis. Okay. And that's, well, it's usually because of accumulation of HCO3 minus. Okay. And if it goes above 8, then it will lead to death. Everything clear so far?
I have a question.
Yeah, of course.
Okay, so carbon dioxide, is it always that like you need to have 20 times more bicarbonate than carbon dioxide? Is it always like that, or?
Yes, well, otherwise you'd experience acidosis or alkalosis. So the balance is having one carbonic acid, so one hydrogen bicarbonate, which is a product of carbon dioxide, compared to 20 units of bicarbonate ions, which is HCO3 minus. If you get
Okay,
more
yeah.
HCO3 minus, you get more bicarbonate ions, then what will happen is you'll get alkalosis. If you get more carbon dioxide than HCO3 minus, then what happens is you'll get acidosis. So it's kind of like a balance.
Yeah, okay, thank you.
No problem. I think someone else had a question.
Yes, I just wanted to know that what are the reasons for acidosis and alkalosis?
So
Why?
yeah, no problem. So acidosis, like we said, is when carbon dioxide concentration increases. This can be for two reasons. Okay, your cells aren't working properly. They're producing more carbon dioxide than they usually do, in which case it's called respiratory acidosis. And when it's because that you cannot expel the carbon dioxide. So let's say someone has an airway obstruction. Okay, now that they have an airway obstruction, they cannot breathe out carbon dioxide, and therefore the pH of the blood, the carbon dioxide that they cannot breathe out, will accumulate in the blood, and then it would cause acidosis. As for alkalosis, is when there's not enough protons, or there's not enough carbon dioxide. Okay, so what happens here is a lot of bicarbonate ions are produced. Bicarbonate, like, hold on. In this reaction, there's not a lot of carbon dioxide, but there's a lot of bicarbonate ions because, well, you cannot how does it, it can also be part of not being able to breathe in oxygen, which then we'll go through that later, because now we have the hemoglobin buffer, which also contributes to alkalosis. But if you don't have enough oxygen, the bicarbonate ions will accumulate, and you will experience alkalosis. If you cannot breathe out, then it's respiratory. Sorry, if you cannot breathe in, then it's respiratory. If it's because of metabolic processes, then it's metabolic alkalosis. Make sense?
Thank you. Yes, thank you.
Yes, no problem. So, speak of the devil, now we have the hemoglobin buffer system. So this is how the hemoglobin buffer system works with the bicarbonate buffer system to complete the oxygen and carbon dioxide exchange system. Okay, so how oxygen gets transferred in the blood is that it just a second, it comes in through your lungs into your alveoli, and it diffuses into the capillaries, into your blood system. And what happens here is that it combines with a protein called hemoglobin in your red blood cells, and it forms oxygenated hemoglobin. And you don't need to know this, but it's because hemoglobin has something called the prostatic group. It has iron in it, and this iron can get oxidized. It takes in the oxygen, and then it releases it at cells. Okay, and why it releases it at the cells, this is where it gets interesting. It's because carbon dioxide kind of changes places with oxygen. Okay, at the cells. So the carbon dioxide released from the cells, okay, partly reacts to form hydrogen bicarbonate, and partly replaces hemoglobin so that the oxygen can be released into the cell. It kind of swaps, okay? So that's exactly what happens, exactly how a hemoglobin and the bicarbonate buffer system works. You also have something called a chloride shift. So how the carbonate ions get released into the blood plasma is by having chloride ions in your red blood cells kind of switch places. So chloride comes from the plasma and it says to the hydrogen, like to the bicarbonate ions, well, I'll go in, you go out. And that's how it's transported in the blood. Hopefully that makes sense as well. I know this is all quite complicated, but usually you take this stuff over a few weeks or sometimes months, but the university is doing it in such a rushed fashion. It's hard to catch up sometimes. Now, all proteins have something called amino acids, and amino acids all act as buffers. Now, what did we say a buffer does? It resists change in pH. So let's say if I add H plus, it will say, oh, no, I want to go back the other way. And if I add OH minus or take away the H plus, then it will say, no, I want to stay in the middle, okay? So protein, general structure of amino acid is shown here. This is called in the middle is called as viterion. You can see that it can accept protons, but it can also can accept protons and it can release protons. So it depends on how the environment is that it kind of counteracts what is happening. Okay. Okay. Checking that there's no one waiting. Right. Yeah. Here we have the carbonate buffer kind of system in the kidneys. You guys can look at this. It's pretty straightforward. I would love to explain it, but we have other stuff to get through and not a lot of time. So on to the next topic. There we go. So sugars, or carbohydrates? What makes a carbohydrate? Carbohydrate. This is the first question. Okay, what is a carbohydrate? So a carbohydrate is anything that has carbonyl and 2 hydroxyls. What's a carbonyl? A carbonyl is a carbon double bound, or that has a double bond to oxygen. Okay, so there's 2 types of carbonyls, but we'll go through that later. And a hydroxyl is an OH minus group or an alcohol group. So you need 2 OH and 1 carbonyl, 2 OH and 1 C double bond O. Okay, and anything that has that is a carbohydrate. And here's a list of some important carbohydrates that with their linear structures. You're going to need that later. So how do we classify sugars or carbohydrates? 3 ways. First way is depending on the type of carbonyl. So we said in the previous slide that a carbonyl is anything that has carbon with a double bond to oxygen. Okay, so this can happen in 2 ways. It can happen in the middle of a chain, or it can happen at the end. Okay. Hello. All right. So keep going. If you guys have any questions, obviously don't be afraid to stop me. Anyways, it can happen at the end. Yeah.
Can I ask? I just wanted to say that in the chat, I saw that somebody wrote a question. And also, I think when you move your hands, the microphone, Mino told you like the mic, we can't hear you always. So that happens sometimes. But yeah, it's going very great. I just want to say that. Thanks.
Thank you. Thanks a lot. Obviously, this is my first, kind of my first time doing something like that. So I'm hoping you guys understand as much as possible. But yeah, I'll try to move my hands less, but it's gonna be hard because that's how I explain. Anyways, to answer the question, sorry, I didn't look at the chat. do they travel into the blood plasma or the red blood cells? So what happens exactly is the carbon dioxide reacts with the water to form hydrogen bicarbonate. This is still all in the plasma, okay, in the red blood cell, okay, and then the hydrogen bicarbonate dissociates into protons and moving hands, into protons and carbonate ions, okay. What happens then is the carbonate ions get transferred into the blood plasma by switching places with the chloride ions that are already in the blood plasma. Did that make sense? Okay. Okay. So now we got something else. Amazing. Okay. Good. So classification of sugars, 3 ways, based on the type of carbonyl, if it's in the middle or on the end of the chain, or based on the number of carbons in the chain. So let's say if we have a carbohydrate made out of 3 carbons, it will be a triose, 4 tetrose, 5 pentose, 6 hexose, and based on the repeating units. So carbohydrates, like many other organic material, are polymers. So they're made out of units, repeating units, okay? So let's say maltose. Maltose is made out of 2 glucose molecules, okay, linked together by something called a glycosidic bond. So you guys can see here, I don't know if you can see where I'm pointing. There is a bond between 2 glucoses, glucose 1 and glucose 4, okay, of their respective molecules. This bond, this COC bond, this is called a glycosidic bond when it happens between 2 sugars. So yeah, you have sugars which are polymers or chains made out of repeating units with glycosidic bonds linking each sugar to the next. So that's so you have, depending on how many repeating units there are, if there's 1 repeating unit, it's a monosaccharide, mono. Di, 4, 2. Oligo is when you have a sugar and something else, like proteoglycans. Okay, so and polysaccharide is when you have multiple, so that's more than 2 repeating units of sugars. Okay, so if you have a lot of glucoses, like glucose, linked together by glycosidic bonds, you will get a glycogen or amylose, which is very important in energy storage. These can, so polysaccharides are separated into 2 categories. You have the homopolysaccharides and the heteropolysaccharides. The homopolysaccharides only have 1 type of monosaccharide. So like glycogen only has glucose, whereas a hetero is more than 1 type of sugar. Okay, so let's say like lactose, glucose, and galactose. Okay, on to the next slide. Isomerism. This is also something that I've seen a lot of people struggle with. So you have 2 types of isomers. Okay, you have stereoisomers and structural isomers. But today we're going to be focusing on stereoisomers. So stereoisomers are 2 molecules that are almost exactly the same, like your hands. Hands are, well, same, okay? But they're mirror images of each other. You cannot put a hand on top of the other and have it perfectly fit. You see the thumbs stick out. But that's exactly what isomers are. So when you get a chemical reaction, you have 2, and you have 1 product, you have 2 ways that the product can arrange itself. So you can have it. Sorry, guys. So you can have it as left-oriented or right-oriented, like your hands. And this happens because the bonds, when you look at them that way, when you look at them the way that they're presented here, they look 2-dimensional, but they're actually 3-dimensional. So, sorry, they're 3-dimensional, like your hands as well. So I like to use that analogy a lot. Or like your mirror reflection, okay? When you point with your right, it points with its left, like you can see in the picture here. Very famous meme. So that's exactly what stereoisomer is. What's an epimer? Epimer is a stereoisomer at one carbon, okay? So only one chiral center. A chiral center, what does that mean? You have, in this configuration that you can see here, all the crosses are carbons. Here, that's a carbon, that's a carbon, that's a carbon. When you have a carbon that's linked to 4 different things, then it's called a chiral center, okay? Like this has a H on this side, an R, a carboxylic acid group, and an amine group, okay? So this is the same. This is a chiral center. When you have chiral centers, then you can have 2 mirror images, okay? And these are called stereoisomers. If they're only chiral at one point, then they're epimers, like D-glucose and L-glucose. One is pointing to the right, one is pointing to the left. So far, so good?
Yes.
Good, good. Now we're going on to anomers. Anomers are also a type of stereoisomers. But here's the thing. Ooh. Okay, here's the thing with anomers. Anomers are different at the acetyl group. All that means is, you see that thing with the box in it over there? That's called an acetyl group. So if they're different, the acetyl group, okay, different configuration, stereoisomers, at the acetyl group, then we can call them anomers, like alpha glucose and beta glucose. Okay, so here is the linear configuration, and second, yeah, there we go. The linear configuration, you can see here, at that carbon, when it comes cyclic, if there's a difference, then it will be, it will form anomers, okay? So now we go on to, now we go on to how sugar becomes cyclic, okay? So how that happens is by something called mutar-rotation, the movement of electrons. So what happens is like a snake eating its own tail, okay? You have carbon 1, you have carbon 6. So carbon 1, carbon 6 react with each other to form a cyclic compound, okay? The carbonyl group on 1 reacts with the alcoholic group on 6, okay? And then you can see the movement of electrons here. And the process by this happens, it's called mutar-rotation. This here, 1, 2, 3, it's called a mutar-rotation. Yeah, and exactly. And when this happens, you can get 2 products. You can get with the OH downwards, which is alpha glucose, or the OH upwards, which is beta glucose. And yeah, that's it. One thing you do might be helpful, like to know, is that beta is more dominant than alpha. So 65% will be in beta form, and only 35 would be in alpha form. That's that part. 2 more slides. Okay, so reducing properties. What does that mean? So we have oxidation and you have reduction. Oxidation, as anyone can guess, is the addition of oxygen, and reduction is the addition of hydrogen, okay? But also oxidation is the removal of hydrogen, and reduction is the removal of oxygen, okay? But it can also be put in terms of electrons. So reduction would be removal of electrons, oxidation would be addition of electrons, okay? So sugars can be oxidized, okay? If we look at only some of them, okay? If we look at, let's say, glucuronic acid here, okay? First of all, let's skip that part for now. If we look at this, the part on the left that I'm pointing at, this is an aldehyde. It has a carbonyl, and this is a functional group in a sugar. It's very important, okay? What can happen is you can add oxygen to it, okay, to form this carboxylic acid, okay? So here, it can accept the oxygen. So therefore, it is reducing, because anything that gets oxidized itself is reducing, and anything that gets reduced itself is oxidizing. I know it's confusing, but that's how it works. So yes, for now, we need to know that sugars can get oxidized, and therefore they are reducing agents. Okay, because you can have aldehydes and ketoses, and aldehydes can get oxidized, whereas ketones cannot, which is why some sugars are reducing and some sugars are not. And how you test for that is by oh, hello, someone wants to say something. Hello. Okay, so now that we know that some sugars have reducing properties, meaning that they can get oxidized, but others cannot. Also, something else, that some disaccharides can get oxidized, but some cannot, because the oxygen becomes trapped in the glycosidic bond, if that makes sense. So here, this is the chemical basis of oxidation and reduction of aldoses and ketoses. The only difference is that here is called aldehyde and ketone, but they are the same. Okay, so as we can see here, an aldose, aldose can definitely be oxidized to form a carboxylic acid. So let's say in this case, a gluconic acid, like we see here, or glucuronic acid. But it can also be reduced to form a primary alcohol, and so do ketoses. So you can reduce some sugars, given the right conditions, of course, to make alcohols and other important compounds like mannitol or xylitol or erythritol. These do not have the carbonyl, so they're not sugars, but they're a product of reduction of sugars. And that brings us to the end of the official lecture. We can go through some questions, and some people have told me that they struggled with the protocols, which I can also go through because I have done it. So yeah, if anyone has any questions about anything that's been said so far,
Can
please.
I ask you?
Yeah, of course.
Can you go to the last, the former slide?
Yeah, this one.
Yes, reaction. You said that anything that gains oxygen gets reduced because of the more of oxygen, the more reduced it gets.
Other way. So anything that gains oxygen becomes oxidized, but it is a reducing agent. Okay, so think about it. Let's say I have an oxygen here, okay, and I have a person. Let's imagine this is a person, okay. Now I say, hey, you take my oxygen, okay. So now he becomes oxidized, but I'm missing an oxygen, so I have lost an oxygen. I become reduced, so therefore he is a reducing agent.
Yeah, thank you. I understood it.
No problem. Okay. So, like I said, sugars can be oxidized, and some of them can be oxidized, and they can also be reduced to form alcohols, which are important in other metabolic processes. That we're not. I don't think we need to go through that for now. So, anyone else? Any questions? Okay, I'll take that as a no. So anyways, to test how much we actually understood, I like to go through questions. You guys can do this in your own time. And if you find, like, these are taken, by the way, these are taken from past exams. I've put them in this presentation. I've got the whole document. We'll need that for later. But these are taken from all the exams from the teachers. Okay, so I think we can try a few questions now to make sure that they were covered in the presentation. Let's see. By the way, some questions also aren't supposed to be easy, so don't worry if you don't know them now. You'll know them later. Okay, so what kind of bonds link glucose units in cellulose? This question we have not covered. So like we said, the cellulose, well, we didn't say that, but cellulose is a polymer and it's made out of beta glucose units. Okay, so you have multiple beta glucose units which combine together to make cellulose, which then makes cellulose. Okay, so what we have gone through though, which is something I'm happy about, is we've mentioned the structure of the glycosidic bond, and you can see here that carbon number 1 here, carbon number 1 is linked to carbon number 4. Okay, and we know that in the question that it's asking about beta glucose because it's cellulose. Cellulose is made out of beta glucose. Okay, so now we can say it's beta 1,4 glycosidic bond, and we know it's an oxygen between the two carbons. So yeah, that question works out. We can eliminate everything with an alpha in it because we know that cellulose is made out of beta glucose. And then we go on to the last option. It says beta 1,4N. N is nitrogen. Nitrogen in sugar, but we don't have nitrogen in glucose, so we can eliminate that. And therefore, the answer is A. List the buffers.
Can I ask a question?
Yeah, of course.
So the beta is, we look at it for the carbon number 1 of the first monomer.
Yes, so that's okay. Can you explain more on that? Because I don't think that.
Like, can you go back to the previous slide that you were showing?
This one.
Right? Like, no, the glycosidic. Okay, yeah. So for the first monomer, the OH is like on the above the plane, so that's a beta, right? But the other
Yes.
one is down there. So for the beta, we look at the first monomer.
Yes, exactly.
Okay, got it.
Yeah. That's actually a great observation. Just a second. Yeah, here you can see the difference between alpha and beta glucose, and you can see that the alpha has an OH downwards, whereas the beta has an OH upwards. So it's hi there. Hi Jacob, you're right. Anyway, yeah, that's a good note that in beta the OH and the H are fixed. Oh,
Hello.
man. Don't make me mute you, man.
Is this chemistry review?
Yes, it is. Sorry about that, guys. Anyways, yeah, here's another question. The change of alpha to beta anomer via open ring chain formation. What's that called? We were talking about anomers not long ago, and you can see that when you change from an alpha form to beta form, before going into the cyclic configuration, it's called mutarotation. Okay, so the OH basically gets flipped over. Okay, so yeah, here's something that we didn't cover: analyzation. So an analyzation is kind of like, so we talked about isomers before. It's kind of changing an isomer. It's structural isomer. So you have an aldoses and ketoses. These are types of sugars that they're interchangeable. You can make one go into the other by a process called analyzation.
What is he expecting though? Can I like raise my hand?
Okay, that's better. You were saying? Hello? Someone had a question, anyone? Right, so I'll move on. So anyways, these questions, they're great. You can You can try any of them in your own time. And if you guys have any questions, you can mark any confusion. You can mark the questions that you struggle with, and we can do them in another meeting. This is just funny because call the structure below this. Very poor English from the university, and you'll see that quite a lot. So,
Will you
yeah.
be sharing the PowerPoint in the WhatsApp group?
Yeah, I will. I'll put the presentation on the WhatsApp group. But like I said, the point of today is to make sure that you guys understand as much as possible. Sorry. So if any of you has any questions or something that I forgot to mention or something that wasn't clear, please do so. Because, well, I'm more than happy to clarify.
Thank you.
Amazing. Good. So I'm going to end the meeting now because it's getting quite late. I don't know how we haven't had to start early meeting. So yeah, last remark. Today, like I said, I have my roommate with me. Yes, go on.
So after this presentation and with all of the knowledge that you've given, so where does somebody studying chemistry for first year go after this? So I've had you present. What do I do after this?
What you do. So first of all, it's something that's very important. You need to know exactly how to do the protocols because these are what the exams come from. These are from the teachers. Okay. So, oh yeah, I did say that I'm going to do the protocols today. You know what? I don't think we have enough time because it's 6:30 now, and we're already over the time that we were supposed to take for presentation. I am going to send the solutions on the WhatsApp group. I might even attach them to the presentation for the first protocol. Sorry about the chat. Anyways, from the first protocol, so I'll attach the solutions there. So yeah, first of all, the protocol. Second of all, the book. Book can be confusing, but it has all the important stuff that you need to know, and it's where I get some of the presentation material.
What book are you referring?
I'm talking to the handbook.
What are the books that you recommend?
Is the handbook of chemistry?
Yeah, handbook of chemistry. This is you can, of course, there's another recommended books on the university website, but the book that has helped me most is the handbook of chemistry. It does have a lot of mistakes, and sometimes it makes big leaps, but it's where they get the questions from, and they're not going to invent questions. Okay, so they get them out of books. One more thing is I want to recommend anything that has to do with British A-level chemistry, because this is the step before. Okay, so all this stuff today, all the knowledge, okay, is from A-level chemistry and from other high school systems as well, but they tend to jump a lot. Okay, so if you don't understand anything, you have Khan Academy. Khan Academy is very helpful, and they can take you through the basics and through the foundations. Okay, so you can go on to do the harder stuff. Okay, and you have physics and maths tutor. They also sometimes have great videos. What else? Yeah, this is basic. It's not foreign material. Okay, it has a lot of jumps and sometimes it's outdated, but you can find it in a lot of high school systems and college systems as well. So as long as you look in the right places, you should find them. Okay, and try to, when you're learning, I would say try to simplify everything as much as possible, because that's how it sticks. If it's something simple, it's more likely to stay in your brain. If I threw just the presentation on its own and the professor's presentation along with it, you guys don't think anyone would understand a lot because it's not very simple. You need to simplify it as much. Anything else?
Yeah, I have a question.
Yeah, go on.
The second part of question number 74. How could I know if it's a reducing
I can't hear you very well. Can you repeat that?
or on the second part of question number 74, how could I know if it's a reducing or a non-reducing saccharide?
Yes, great question. So what we were talking about before is reducing, meaning that it's able to be oxidized. Okay, whereas non-reducing means that it cannot receive another oxygen. Lactose here is reducing. Why? It's because if you look at carbon number 1 and carbon number 4, there's a bond there. This bond can be broken if you add another oxygen to the mixture. So therefore, you can oxidize lactose. You can oxidize lactose, and therefore it is a reducing agent. It is a reducing product. This, and also there's some stuff that you just need to know. So lactose is a reducing because it can be oxidized. It's a reducing agent. It's a reducing sugar. Whereas other disaccharides, well, most of other disaccharides cannot be reduced. So let's see. A famous disaccharide that cannot be reduced. Any saccharide apart from lactose.
Sorry, what's broken? I couldn't hear you well.
The glycosidic bond, so the oxygen to oxygen.
But I can see it. Isn't the glycosidic bond? It's between the two molecules. I can see it.
Exactly. It can be broken by the addition of oxygen.
How did you know it's broken?
Sorry?
How did you know it's broken? I can see the glycosidic
Yeah. It gets broken when you add oxygen.
bond. I can see it between the two molecules.
Yes, exactly. So when you add oxygen, it gets broken because it's able to be oxidized. It's able to receive that oxygen. Does that make sense?
So basically, most disaccharides are oxidized.
No. Yeah. Okay. Look, most disaccharides are oxidized, and most disaccharides are reducing. No, wait. Most disaccharides aren't reducing, but lactose and maltose are. That makes sense. I might be mixing it up actually. Hold on. You should have, like, if you Google it, you should have a list of reducing and non-reducing sugars. And disaccharides are mostly non-reducing, but there are some that are reducing.
I had a question. Like, what is the first thing we have to see when we are looking at a reducing or a non-reducing sugar?
So what makes a reducing sugar, and what makes a non-reducing sugar non-reducing sugar?
If we have to tell whether the structure is reducing or not, how would we tell it?
I would say by looking at the glycosidic bond. So I'll just, it's one person that I go reducing versus who is your friend when you cannot remember. So yeah, there we go. That's a good picture. An example of non-reducing sugar is sucrose, and what you can see with sucrose is that you cannot add another. I don't know if you guys can see it. It's still loading. You cannot add another oxygen because it's fully occupied. Okay, it's like all the oxygens are double bonded. Okay, but whereas in glucose, you see the OH. First of all, there's something called valency of the elements, and for oxygen, it can have 2 bonds. Okay, now you have a weak bond here, an O and a H. Okay, so this is a weak bond. So this, you can add another oxygen to it, and it becomes carboxylic acid. Okay, you can oxidize it. Okay, and that's what makes it reducing, because it can get oxidized. It can get rid of that hydrogen. That hydrogen is weakly bound. Whereas here, oxygens in sucrose, you see the oxygen is double bound. And so same with this molecule. It's very strongly bound. It's like you cannot get rid of any hydrogens. Whereas here, you can get rid of that hydrogen, and therefore it becomes oxidized. Does that make sense?
Yes.
Good.
So can we say that all disaccharides are non-reducing?
Not all of them.
monosaccharides
Lactose and maltose are reducing.
reducing? Okay, thank you.
No problem. So most of them are. You're right. But Oh, damn. And yeah, that's it for today. Anyone got any more questions? Oh yeah, I forgot to mention, this is my flatmate, everyone. This is my roommate. His name is Haitham. Okay, as you can see, I've got very beautiful pictures of him here. He teaches anatomy. So this guy is one of the best people I've met that teach anatomy. He helped me get through my exams, my anatomy exams. He helped me get through Suritsky. He posts online videos on YouTube teaching anatomy and answering any questions you might have. I think you guys have only taken about one or two anatomy classes. So far, I think is going to be okay. But as you go along with the anatomy, you're definitely going to need him. And he offers also meetings like we're doing today, webinars, answering questions, maybe clarifying something that's a lot of people find confusing. So yeah, this is him, everyone. Do you want to say hi?
Yes. First off, I want to thank you for Kareem and I, guys, we've been living for the past year together and learning along with him these subjects in first year were actually very interesting. And together, because we were always together motivating each other to study, we've reached to where we are right now. Wanted to just point some words about our future plans together with Kareem. About anatomy, first of all, Kareem and I will be creating webinars as a form of Q&A sessions to clear your doubts and maybe discuss some hard points that you may be bugged about in anatomy. Also, I have a YouTube video posted for every single point on your syllabus, and I've seen it and he've changed it a little. Every week or every 2 weeks, according to your request. I'm going to try my best to help guide you guys on studying for your osteology, which is your first upcoming oral exam, plus guide you on studying your pins for from now to your pins exam. That's for anatomy, and I will discuss when you guys prefer the webinars to be carried on the big group. Finally, also Kareem and I will be collaborating to run biology webinars as a form of Q&A. Think it's a little simpler than chemistry. So yeah, this is my addition, and thank you again, Kareem.
No problem. Okay, thanks everyone for coming today. I hope it helped. Oh, there's a question. Should we be scared for chemistry? Absolutely not. As long as you cover the most you can, so as long as you go over the book and you can answer most of the questions and you can answer all of the past questions and everything, and if not, you can go back to your books. You can go back to Khan Academy. You can go back to YouTube. YouTube is very useful as well. You can come back to me, ask me any questions if you cannot answer them, and you should be okay. Like we haven't struggled with chemistry at all. We did have it online, so it was less pressuring, of course. But I don't think that you guys should be scared for chemistry as long as you do your part. So do protocols, do your questions, and you'll be okay. Okay, so that's it for today. Thank you, everyone, and thank you.
Question about anatomy.
Thank
Please,
you.
Dunya was asking, where can we find old anatomy questions? In a way, anatomy is run continuously to have similar system every year. So for your anatomy, you will have the same 164 issues tested at the end of the year. And I'll tell you more when we meet. Don't worry about that.
Amazing. Thank you very much. Have a great have a great evening. What is the anatomy classes? Yeah, we got another question here. What's the YouTube channel for anatomy? Haitham, do you want to write that one on the chat? Anyone, by the way, you guys are free to leave if you're if everything is clear. There we go. That's his YouTube channel, and you'll find all the videos on there.
ملك يا كريم والله. لاعب عليك موجودين وابن عمك.
This is my other roommates, everyone. That's for everyone who's still here.
Karim.
Oh, hi.
Hi, I was just gonna ask, like, sometimes it gets lost what you sent in the WhatsApp group because so many people text.
Yeah.
Is it weird to ask if you guys could make like a Facebook group for us and then it's easier to share only documents or important information?
Yeah, of course, I can do that. I can do that. Yeah, I'll definitely do that. It's actually a great idea for the future as well. Thanks.
Or a separate WhatsApp group where you can change the setting to only admin so that no one can spam it, and then you can put the documents in there.
Yeah, and also for today, so for today's presentation, oh, I should have said this before everyone left, but for today's presentation, if you want me to send it on private chat, just send me a hi or can I have a presentation or whatever, and I'll send you the presentation as well. I'll even send the recording for today's lecture.
Thank you.
Okay, man. Thanks so much. This was great. I'm sweating so much. Man, just call me on the Zoom meeting. You're still in. على ايه؟
مفيش حد هلا.
والله يا كريم عالمي.
والله عالمي برو.
حبيبي برو.
انت بتعرف تبعت الايديا تبعت انه اعملوا واتساب جروب عشان الريسورسز او
Yeah,
فيسبوك
and
جروب.
Facebook group as well. That's so
Bro,
genius.
me, you, Muad, and that's it.
Yeah, let's do it. Let's do it. We're the admins.
Alhamdulillah, perfect. And we're gonna do it as the same system as Magda does for news, second year news.
Magdalena called me. I need to call her back. I don't know what she called me for because she never ever called me.
It's fine. فكك منها. بس اسمع هلا في ناس حفلوا عليك ترى.
I know, man. Fuck them. I don't care.
عاد عرسنا لك احنا.
حبيبي. Did you
اسمع.
fuck them up?
Tomorrow, like when you're done, like rest today, we will take a phone call to arrange everything, and like start working because this is actually really nice.
Good. Amazing.
No. والله يا كريم,
I'm so excited. Look.
والله I'm جد.
Huh?
I'm just so proud of you, bro.
Man, I'm proud of you. Thank you so much. Like this idea is actually, you're the one that pushed me to do all this, you know?
الصراحة like you got it, man. You يعني everybody seems safe with you, you know, and I'm just so proud, bro. والله.
And Allah, the pleasure is all mine. Okay, guys, I have training in a bit. So I'm gonna go get fucked by English Donnies because rugby.
يلا روح.
Yeah, I'll go. Anyways, thank you so much, guys. Thank you, Haitham. Did you see the pictures that I put?
I was just laughing at it, man.
Okay, man. يلا سلام معاذ. سلام يا باشا.
هلا بس هو بيحكي تليفون خلاص بسلم عليه.
Okay, bro. يلا سلام.